Okay, factoring review, this is 2f. Okay, wow, what a gross question here. But take a good look at this here. I've got 3 terms. Now, I know that's sometimes a little hard to see, but those parentheses there, put this all together. That's 1 term, that's 2 terms, that's 3 terms. Now, look what you're seeing a lot of. I'm seeing this in brackets here, or in parentheses, a squared plus b squared. A squared plus b squared, a squared plus b squared. Now, I don't know what a is. I don't know what b is. So put that together. I don't know what a squared plus b squared is. I have no idea. So I'm just going to introduce another variable. Let's just call it c. And I'm going to call that a squared plus b squared. So this whole thing then becomes 3y squared c minus 11y c plus 6c. Well, that's a lot easier to look at. And when I look at this trinomial here, now I can see quite clearly, oh, that variable c is common to all 3 terms. So I can pull that out. And that leaves me with 3y squared minus 11y plus 6. Okay? Now I can approach my trinomial the way I've been approaching it all the other ones here. I'm going to take that 3y squared, I'm going to multiply that by 6. So I'm looking for two terms here whose product is 18y squared. Oh, I don't know why I put a little line there. Hold on, I don't normally do that. But I'm looking for 2 terms whose product is 18y squared and whose sum is negative 11y. Okay. Now their product is positive, their sum is negative, which means these 2 are both negative, and it shouldn't take you too much to see that that's got to be negative 9y and negative 2y. Now remember, these 2 are not necessarily the values inside the binomials here. Okay, this is going to be the outside product, and maybe the other one is the inside product. So now the first 2 terms in both binomials should have a product of 3y squared, and then that first term multiplied together with that last term should be negative 9y. Now if you think back to what we have said before, that negative I'm going to incorporate over here just as a habit. I'm going to put that over in this term right here. So this term here, I'm really just comparing the 3y squared and the 9y, and the biggest factor I can think of is 3y. So if that's 3y, when these 2 terms are multiplied together, the first 2 terms in each of these, the product should be 3y squared. Well, there's 3y, so there should be another y right there, so that their product is 3y squared. 3y multiplied by this should get me negative 9y. Well, that means this over here has got to be negative 3, because the y is already there. I just need those 2 to multiply to get negative 9. This term right there, multiplied by the last term in the first factor, their product should be negative 2y. Well, there's the y, which means this must be negative 2. Now, normally, that would be it. However, I'm going to erase this right here. Okay, and I haven't done this before, but the reason I'm doing this right here is because I've got a c in this problem, and that c shouldn't be there. It was not part of the original question. So what I got to do now is put back that a squared plus b squared back into this question. So now this becomes a squared plus b squared multiplied by 3y minus 2 times y minus 3. And that's the factored form of that expression.